Right, good morning, AP Calculus. We are going to finish up the notes today, which is great. We have 4 word problems to go through, and so let's get started. All right, so our first problem reads, suppose an experimental population of fruit flies increases according to the law of exponential growth, okay? So we know what that means from our last video. There were 100 flies after the second day of the experiment and 300 flies after the fourth day. Approximately how many flies were in the original population? Okay, so here's one where we don't know the initial. And just sort of right away, when you don't know the initial, sort of think system of equations. Okay, we're going to need a system, and then we'll sub back into the system to continue to solve and using our 2 data points there. All right, so let's get started on what we know. Okay, so our 2 data points then are going to be day 2, 100 fruit flies, and fourth day, 300 fruit flies. Okay, and law of exponential growth just lets me know that we're going to be using amount, and you can always just memorize this with PERT. PERT is a perfect law of exponential growth equation that's easy to remember, and it can help you write these. Not that these are difficult, but law of exponential growth involves that naturally occurring number e, which naturally occurs like pi does in a circle in exponential growth problems. So we have the initial amount, which is what we're looking for here, e. And PERT calls it a rate because it is. Usually we call this a K and then time. All right, so we've got 2 data points, so we'll put those in. We've got 100 equals a to the 0 e to the k times 2. And we've got, I'm going to write them across from each other here, 300 equals a to the 0 e to the k 4. Okay, we're going to solve both of these for a to the 0, and if we're solving both of them to they're going to have the same initial population. It's the same initial population, just assessed on day 2 and day 4. So I'm going to solve both of these for a and set them equal to each other. It's pretty straightforward. All right, so let's cross multiply this up. Okay, and I can just really switch those 2, but I'm going to go through the motions. So that's 100, 300, right? Okay, and then I'm going to divide out. I'm kind of going in circles here, but this is going to be 300 over 100, right? And then e to the 4k over e to the 2k, just so you can see, cross multiply this up, and then get things on the same side. But really, I could have just set this, I really could have just pulled a switch right here on those 2. Okay, so this is then e to the 4k minus 2k equals 3. That's e to the 2k equals 3. ln, I'm going to go and pull that down. Okay, and then k is going to equal ln of 3 over 2. Okay, and so ln of 3 over 2 is, I'm going to keep that intact, not go to decimal yet, because I've still got to find the initial amount. Okay, so now what we're going to do is substitute k back into either original. You choose, just like you do in algebra, either one, whichever is easier. These are both pretty similar. So I'm just going to use 100 equals a0 e to the ln of 3 over 2. I guess this one's easier because those 2's are going to cancel. Okay, so this is just going to be 100 equals a sub 0 e to the ln. That's an inverse. So I've got 100 equals 3 initial amount, and divide by 3, divide by 3. 33.33 is the initial amount, but this is a species, so we'll say 33 fruit flies. All right, if I could change the notes in the formatting, I'd change it to fireflies. Instead of nasty fruit flies, I'd change it to cute little fireflies. All right, there we go. Problem 1, done. All right, next one. Oh, wow, look at this. So, I'm going to just pause the video, give you guys a chance to read through it. You certainly don't need to sit here and listen to me read through it. So take a second, read through it, and we'll get solving. Okay, so it's definitely a lot of information there, and a lot of it you don't really need. So sometimes that's the trick, is muddling through problems and seeing what you don't need. The first thing I want to mention, though, is remember the half-life formula we used in pre-calculus, okay? So half-life formula we used in pre-calculus was, y equals, or even we could even go just use A, and we did the initial, right? And we had the base for 1/2, and then you raised it to t, and it was over n, and n was this half-life. So in pre-calculus, you're just given that formula to use. And in calculus, you actually see where it comes from. So we'll go ahead and derive this one. You could just jump into the problem straight away and use the law of exponential change here. So e to the kt. You could jump in right here. And we're going to show how this turns into this, and it's with that maneuver that I did on the previous notes. But this, and we could say by law of expo change, just remember PERT. You ever put PERT down, law of exponential change on the AP exam? But I'll go through this one more time, and then on the next page I won't. So again, we're just trying to write the half-life formula here. We're not really going into the second data. We're not talking about what's happened at this problem where this person is digging. We're just trying to use this information here, that half-life and years, and just to get us to this point. Okay, so dy, or if this was dA, we'll just use dy over here, dt, you get that k, right? You get the k and y. So this is when the rate of change is proportional to the amount present. So not to the time, to the amount present. So y would be the amount present, or a. So with this half-life, it comes from the rate of change is proportional to the amount present. Okay, so you separate your variables. Integrate. ln, absolute value. kt plus c. Exponentiate. Knock out. Separate. Assess absolute value. Let say, you could even say a sub 0 equal plus or minus EC. Okay? And so there you are. And we could even say let y equal a. And so that gets us to this formula by the law, the one that you could start with. Okay, so what are we going to do to this formula? So we're going to try to find this k value here. We're going to plug in our initial amount, and we don't know it, and that's okay, because we know this is a where do I see half-life written? Oh, there. This is a half-life problem, okay? So this is going to be half there. Okay, so that could just go off both sides, and we've got e to the k, and we know this occurs at 5,700 years. So we've got 1/2 equals e to the 5,700k. ln, okay, and we're just going to divide that out. I'm running out of room, so I'm going to do like that. Okay, you can probably see how this is going to transition to here now. So that's your k value. Okay, so the formula then in general is a equals a to the 0 e to the ln of 1/2, and I'm going to take this did I do it again? No, we're good. I've got it written in the correct. So ln, and I have this t here, right? And I'm going to move this, I'm going to move the 5,700 over and kind of slide that to the right and write my new formula. So slide it to the right, so right here. All right, so this is A equals A0 E to the ln of 1/2 raised to the, little ladies in the way here, raised to the 5,700. Okay, so that cancels. The 1/2 drops, and you've got t to the 5,700 there. Okay, so now let's answer the question. So that was just derivation and then further kind of showing you how these equal. So here's the problem. We're wanting to say that they've come across, we know the formula for this particular substance, and we see that they've lost 22% of their original. So what is, happening here is you've got your initial, we still don't know what that is, but now we've got 0.78 of the initial. And we're going to use our easier formula here. If you don't want to transfer to this formula, you don't have to, but it's actually easier to work with. All right, and so we're just going to ln 0.78 t over 5,700 is going to come down. Ln of 1/2. Okay, and so let's clear out t. So it's going to be 5,700 times ln of 0.78 over ln of 1/2 is our time. So could these scrolls be 2,000 years old? Well, let's see what time passed for this to happen. 5,700 times ln of 0.78 divided by ln 0.5. Okay, so the scrolls are 2,043 years old. We'll just say that. So yes, they are more than 2,000 years old. I'm off the paper. Yes, I'm off the paper. Okay. All right, so I'm going to, this is getting kind of long, so I'm going to pause the video, or I'm going to stop the video and just do a second video for the second 2 pages, I think. Okay? I think that'll work better. All right. Thanks for tuning in. All right, we'll see you guys on the next video.